My dear students, how are you? I hope you all are very well. I'm Richard Kokonpal, uh, science teacher of Milestone College, class 6. Today I will take your science class about chapter 11. Our title name is Force and Simple Machine. And today I will discuss the lesson 5 to 11. Our online CW class is 59. So, what topics today I will discuss? The comparable advantage of different simple machine. So, students, let's get started. So, what I will discuss? So, students, I already told the comparable advantage of different simple machines. So, what we have seen here? Yes, you are absolutely right. That is different types of forceps. That means these forceps are the medical tools the doctors are using for different purposes. So easily you can understand that what we will going to learn actually. First of all, we should know what is actually lever mill. Do you have any guess? Yes, you are absolutely right. So lever is a such kinds of machine. Just you can say it's a simple machine, isn't it? So these simple machines, we can do lots of good work. And though it is simple machine, but after that, it can perform a good or excellent work. So if I say the definition of machine, so what actually we have seen? Let's see. Lever is a simple machine in which a strong bar can freely move upward and downward or rotate on a supporter. That means this lever need a definitely the concrete supporter. Without supporter, actually the lever cannot work. And when you use simple machines, you can keep something upward or you can keep down something downward. Okay. Students, if you see this image, you can easily understand. So what is this? Yes, this is a supporter, and if you see this is a stick. So this is the stick is work as a lever. Okay, so when you give the pressure here, so that means you are using or performing your pressure here. So you can say this is a force sum. See these pictures. This is a force sum. When you apply force here, so that means the load arm go upward. Okay. When you just remove the force here, it will again come to its own position. Okay. So if you see this machine, this image you will see the force arm is load arm, and this you can say the fulcrum or pivot. Okay, so here is also an applying machine. That means all machine load is working here. That's why they need a supporter. If you see the types of machine, have you any guess? Yes, you're absolutely right. The levers are divided into three types. One is class 1 lever, number 2 class 2 lever, and number 3 class 3 lever. Okay, so let's see what is the functions and how actually the looks of different types of lever. So students, if you see these things easily you can understood. The levers can classify into three types on the basis of applied load and pivot. I already told that is what is the pivot means. Pivot means the supporter or fulcrum. That means where the levers actual the force is worked for. Okay, and that is class 1 lever. In this case, the position of the pivot is in the middle of the applied force and the load for example. For example, scissors, forceps, and balance. So students, now you understood. So what is the examples of class 1 lever, isn't it? So it is very simple. Just you keep these things in your mind. That is where the pivot actually working. Okay, the pivot is in the middle of applied force. So these things is very important for the class 1 lever, isn't it? So let's see about the image of class 1 lever. So this is what, this is very common tools in our day-to-day life, that is scissors. We use scissors for different types of work, as well as the tailors or the different types of people also use scissors for the different types of work. And beside of the scissors, so there is the balance. So do you know what balance actually do? Yes, you're absolutely right. This balance is used to weight something. The balance one plate using some measurement and giving some product is there. So when the both the place is same, that means keep balance, we can say that one's the balance of that product. Okay. So what actually balance do? Here, if you say about the lever, so this one is the pivot of fulcrum. The both the both the plate. Here you can give the load arm, or if you give here any pressure or force arm applied, so both the plate keep remain balance. Okay, so let's. If you say about the class 2 lever, in this case, the load remains in the middle and the position of the applied force and the pivot are on the two ends. Okay, can you differentiate between the class 1 and class 2 lever? Very simple. For example, nutcracker, one wheel push cart, bottle openers, etc. Okay, this is the pictures of bottle opener, and this is the one wheel push card. The bottle opener, when you use these types of machine, here we are using the force arm, and when you keep here any force, so that time the the cap of the bottle will be open. And for another example, the one wheel push card, that means here you are pushing the uh, energy or power, so that time it will be moved. And here is also using the supporter, that means the support is creating here and here also. So both the places it used as a pivot, isn't it? Okay. Can you understood what is this? Yes, you are absolutely right. That is nutcracker. When you keep the nut here and apply the force here, so easily you can cut the nut. Now we will see what is the class 3 lever. Class 3 lever, in this case, the applied force ineffective in the middle. The load and pivot remain on the two edges. For example, pinchers. Now we'll see how we can do work easily with scissors, nutcracker, and pinchers. That means the beside of after this slide, we will see the different types of functions of these three common tools. Okay, this is class 3 levers example. So student, listen very carefully. This is a stapler, this is a very common tools, and when you giving here paper, so you just push here or energy and easily you can staple. And this is the effort arm and this is the load arm. So this is a good example of class 3 lever. Now we will see the uses of scissors. Firstly, at the time of cutting something, say clothes by scissors, it will be much easier to cut the things placing closer to the table. Basically, in this case, the mechanical energy is increased by trying to decrease the length of load bound. Okay, this is the different types of scissors image. All the scissors is not using the same purposes. Some scissors also doctors use, and the doctors use scissors are different types. They also use to cut something in the different types of surgical place. So they use the different types of work. Okay, the use of nutcracker already I told the uses of nutcracker. After that, you will see in case of nutcracker, the closer the pivot is to the load. For example, betel nut, the less force will be required to apply. In this case, we get mechanical advantage also by decreasing the length of the load arm. That means by increasing the length of the force arm. That means if you think about the nutcracker, so nutcracker when you give the nut inside the cracker, so that time you are giving less energy. But where you the force actually use on the nut, there will be more energies applying there, and easily the nut can be crash. Okay, so see the actual figure of the image of nutcracker. You can use the nut here, and you are applying the force here. So easily you can cut it. Now, students, just see the uses of pinchers. First of all, we already have seen that uses of other two tools. Now, third number. In case of grabbing a substance by pinchers, the closer the pressure of the finger to the substance, the easier it will be grab the substance. Here also basically increase the length of the force arm. That is by decreasing the length of the load arm, the work is made rather easy. That means when we use some lever, I already told our work can be easy and more comfortable. And definitely we can use the less energy and do the more efficacy. Understood? Can you recognize the things? Yes, you're absolutely right. That is the good example of pinchers. You know, these pinchers we are using especially if you go to any kinds of festivals or any ceremony. So that time we can use these things to take the piece of fish or piece of meat or any kind of piece of another things. Okay, so we are using these pinchers. So students, lesson 7. So uses of hammer and forceps. Let's see what is the uses of these common tools. Uses of hammer. There are generally two ends of hammer. You know the hammers are a very common tools in our day-to-day life. Not only we use hammers, different types of people also use hammers for different types of work. So let's see. By one end drive a nail into wood, and by another end it parts nail out of wood. When nails are packed by hammer force in applied by holding the hammer's handle by the hand. So let's see. So if you say the uses of hammer, against a nail parts by pressing the hammer against the area surrounding the nail, which junction as a fulcrum. In this case, the resistance against pulling out of the nail functions as a here as the fulcrum was in the middle. It functions as a class 1 lever. So let's see hammer. So see, this is the image of a good hammer. This is the one portion and this is another portion. This portion is easy to pick up the nails into the wood, and this one is remove the nails from the wood. So see, there is third, there is face, head, cross, eyes, handle, grip. So these are the different parts of hammer, and you know this is a very essential tools in our life. So students, uses of forceps. Forceps also act as a lever, the end where the hand holds the force in uh, the forces in the force forceps in the force and the end where the substance is grabbed act as a weight or load. Here the pivot remains at the middle. So forceps is included in class 1 lever. So this is the example or image of a forceps. You know the forceps also using different types of work. Something in need to cut, something is also some forceps also used to actually take the nails from the wood. Okay, so this is a good image of a forceps. Now, students, we have completed so many things. Now we will know about the inclined plane. Okay, inclined plane is a simple machine with the help of it a heavy body can be lifted by sliding it rather than raising the body vertically. The work can be done quite easily by using an inclined plane. So, it to accent a high breeze, the load is made stunting and reach the top floor of a building. The staircases are made inclined instead of making them vertical to raise a body by sliding over an inclined plane. Although the distance reversed by the body are to no mechanical efficacy. Students, do you understood? Formula of the mechanical efficacy of inclined plane is the load weight, okay, equal to the length of the inclined plane divided by height of the inclined plane. That means first of all the mechanical efficacy, the load divided by force, equal to length of the inclined plane divided by the height of the inclined plane. You remember this formula. This is very important formula in this chapter. Okay. Wow, can you recognize the things? First of all, you see these pictures. It is jack screw. Sometimes those who have car, if the car tires is just punched or puncture or the it will if any problem, so you need to change the car wheel. So that time, these tools is very, very important, and this is very essential tools. It's jack screw. When you just rotate the things, that it will be go up, and easily you can remove car or change car wheel. Okay, and this is the inclined plane of sometimes it is very difficult to keep any heavy things from the downward to the upward. So if you use the inclined plane, so easily you can just push here, and easily it can be go into the upper direction. So see, the one person is pushing the backside, and easily it go up. So jack screw follows the principles of the lever and inclined plane at the same time. The height of the portion of the twisted screw is the height of the inclined plane, and the distance traveled through the twisted path is the length of the inclined plane. Mechanical advantage can be availed by increasing the length of the inclined plane. On the other hand, the direction in which the force is applied on the handle, the load acts in the position direction. So, by increasing the force as well as changing the direction of force, jack screw makes a work easier. I already told when we need to change the car wheel or do any corrections. Okay, so jack screw is a very important lever to do some work. Now, pulley. Pulley is one kind of simple machine. There is groups small wheel dish from a rope is hanged from two sides. The pulley rotates around an axis rod which is connected with a fixed block. Pulley is generally used in lift heavy bodies or to collect water from the well. Okay, students, how many students saw these things? I hope those who actually went the village area, especially in where the some village people use the actually pool water from the wells, so they use this pulley. And here the people are actually pick up the bucket, and here the wheel is rotated so that the water is come up. Okay, so other example, if you see the when the people actually wants to be pick up the flag, so they also use the pulley to hoist flag. and this is very important. The people use to do that things. So students puller may be static or dynamic. In a static pulley, the block remains at rest and only the disc rotates. On the other hand, in a dynamic pulley, the block is no at rest. It rotates with the rotation of the pulley. So the mechanical efficacy of pulley, the length traveled by the force divided by the length traveled by the load. You remember this formula as well. Very important topic, that is wheel road axis. The wheel road axis is one kind of simple machine. It is originally different from of lever. Here wheel acts as the force arm and road axis as the loader. The load is sustained by one end of the rope and the rope is rolled up by rotating the road axis. Its mechanical advantage depends on the ratio of the radius of the wheel to the radius of the road axis. So see, this is whole road axis image, and you have seen these things. Now, that means if the radius of the wheel is 6 times greater than the radius of the road axis, 6 kilometer weight load can be lifted by applying 1 kilometer weight force. So one thing is clear, that to increase the mechanical efficacy of wheel road axis, the radius of its wheel need to be much greater. The wheel of motor car, screwdriver, etc. work like wheel road axis. Students, you know, when you open some screw with a screwdriver, so that time we are using the wheel road axis. And this is the good example. You know, the through the screwdriver, when we apply the force into the screw and we are just rotate the screwdriver, so easily the screw open from the wood. So now, students, have a related question. We have learned the lesson from 5 to 10, and now we're going to see that what types of related question is here. Number one, explain the class 1 lever with example. Number two, explain the class 2 lever with example. Describe the class 3 lever, mentioning the position of lever. What types of lever hammer is explained. What types of lever forceps is explained. Describe the inclined plane and pulley. What do you mean by the wheel rod axis? Formula of mechanical efficacy, then formula of mechanical efficacy of pulley. So these related question you will must learn. This is the end of our today's class, and I hope you all understood the chapters very nicely, and I have given the maximum answers in the slide, and you will learn those relative questions I have given. So, and I hope you have no problem and you easily learn the full chapters, and when it is come in exam, definitely it will do for you. So bye bye all of you.